Hello everyone. Let me introduce myself to you. My name is Prasan, and I am from Data Science section, fourth second year, fourth sem. So we all know that how to write a C programs. We write the code and compile it and get the output. But have you ever wondered what actually happens inside the compiler? So how does a machine understand our code? And so today I will demonstrate how a simple C program is transformed step by step from plain source code into a powerful representation called a code property graph, or we can call it as a CPG. Okay, we will directly move on to the our project section where I have created a GUI, or you can call the interface, to showcase how this works like here. So as you can see, this is our code here. Like we have index.html for this whole structure. These are like a skeleton for structure, and these are JS files for this. So this is our main JS files, CSS and other files. So we just head on to the our main section here. So as you can see how we are working, like here's from the source code to the tokens and parsing in control flow, and then the data flow and the unified representations working here. Like this tool visualizes the journey of a C program here. It shows how source code is analyzed structurally and computationally. Each stage gives us a different perspective of the same program. Finally, all representations combine into a unified model called the code property graph. So we can just simply move on to the first assignment program, like simple assignment. Like you can see the code here. So let's begin with the simplest program. Like here, two variables are assigned values. A third variable stores their sum, and finally the result is printed here. Um, so does okay. Let's just generate the analysis here. Okay, the analysis is over. Like you can see here, like nine lines of code are there, and total tokens are 35, variables are 3, two functions, and AST nodes are 25 and CFG nodes are 8, 7 DFG dependencies to 21 CPG connections. Like how many keywords, identifiers, constants, operators, delimiters, literals and others are there, it can be seen here. So okay, we will just move on to the lexical analysis. So the first stage is lexical analysis. Here the program is broken into smaller units called tokens. Like you can see, here int c is equals to a plus b printf. So here the keywords are identifiers, operators, constants and symbols are recognized. Think of this stage as a splitting a sentence into words. Okay, so this is another stage. Like here, this is the AST stage. So next comes here the parsing. So the parser checks whether the syntax follows a C program, a C language program. Okay, the output is the abstract syntax tree. So notice that addition is represented as a parent-child relationship. Like it is a parent one. These are all the child relations. Like this ADC. These are the these are children for this parent node, and these are all the child nodes for this parent node function name. So this trace tells us that what operation happens and in what hierarchy. So if lexical analysis gives word, so this AST gives the grammar for this. Okay, Next is the CFG. So we can say in this CFG, control flow graph, this one shows the order in which statements execute. So since this is a straightforward program, execution simply moves from top to bottom. Here you can see the execution start from the top to bottom here. Okay. Next is the DFG one. Data flow graph tracks how values move through variables. You can see here carefully. So the value 5 flows into variables and the value 10 flows into variable B. Both contribute to C here. If we consider 5 and 10, so the value 5 flows into variable A and the value 10 flows into variable B. So both contribute to C. Finally, C reaches to printf here. So DFG answers where did these values come from. Okay. Okay, now this DFG is over. Next is the CPG here. So finally we combine all the analysis, and AST gives a structure and CFG gives the execution flow and DFG gives data dependencies. So together they form the code property graph. Okay, so the CPG is widely used in vulnerability detection, malware analysis and static analysis and software security tools. Okay. Okay, this was about the first program, and if you go on to this like if else program, those all things will come here. Here you can see we have used the if else programs here. So the previous example had only sequential executions. Let's see what happens when the decision making is introduced here. Okay, so the biggest change appears in the control flow graph here. Okay, as you can see, notice how this execution splits into two parts. One branch executes if the condition is true, another executes if it is false. Yeah. So these branches later merge. So think of it like reaching a road junction here. Okay, and you can see the DFG also. Even though there are two possible paths, both eventually uh, affect variable C. As you can see here, these both affect C here. DFG captures these dependencies. Okay, these all will come for this again for the nested if. Okay, as you can see that DFG is changed here again, as we have. So this increases the complexity here more, as you can see here the CFG of the for this nested if. And so next, for these all programs I will generate, I will just show how does this all show the graphs. Okay, this one is for this one and DFG. Okay, up to 10 program, these are all the programs here, like as we have 10th program, complex programs we have, like these are all depends on these programs. Like we can see how the lexical analysis works. This is a perfect example like showing this UI, which helps everyone to see how those things works here, like the parser or the lexical how works, like and the CFG and DFG and CPG. These all will we can understand very easily. Okay, these are the things which I have to discuss here. So to conclude, this project bridges the gap between the writing code and understanding how machines interpret it. So by visualizing lexical analysis, syntax trees, control flow, data flow, and code property graphs, we can go deep insights into program behavior. Such representations form the foundation of modern static analysis and vulnerability and scanners and intelligent software engineering tools. Okay, thank you so much for being here. Thank you, Shanti.